Now let's look at what we're actually going to do in the lab. This is a close-up of part of your lab notebook, and I wound up what I call the mass 2. We'll see how we do that in a second. I wound up putting that on the left, which I actually found confusing, but I've already done it that way, so we'll just have to get used to that. And this is where we're going to have the center mass. Okay, my pivot point is where we set it. I call it my pivot point because that's physically where the yardstick is sitting, and I'll show you that in a second. So you have a force up, and my naming notation, if you can get used to it, is it goes, this is from pivot to force 1. This is from the center mass to force 1. And again, our center mass we saw earlier was where I could replace the whole stick with the mass of the stick, and it would act the same way. We'll show you that in a second on the actual lab setup. So that's the naming. So this is from 2 to 1. So from force 2 to 1. Here's our lab setup. You won't have the cardboard there. I just had it. It's almost impossible to get the yardstick to balance perfectly where it stays. Sometimes you can, but usually it'll sit there a while and then start to tip. So I had the cardboard both to give me a better background and to just add a little bit of friction. This is your pivot point. Your center mass, your instructions will tell you the first thing you need to do is with nothing on the yardstick, you need to find where nothing except this silver piece here that you balance it with. You need to make sure that 50 is the center mass, but see if it balances at 50. Most sticks, that's probably where they're going to be. So in this case, mine did. It balanced right at 50, so that point right there would be my center mass, and this is my number 1 weight over here, and this is my pivot point right here. Here's a close-up of how I measured it. This would be at the position 85. You just read it right off the yardstick, and I had my yardstick reading left to right. So this would be position 85. And you can see right where it sits, where it marks. So your instructions will tell you, as I just said, you weigh the hanging mass and the mass hanger, and in my case I got 0.066, 0.121, and this is the mass of the yardstick. I put cm because that's the mass that's going to be at the center mass location. So I got 0.139 and multiplied by 9.8 to get my forces. You only have to do that once. These will never change. Your pivot force is going to be the summation of all the other forces, because just like we did in our diagram earlier in our example in the intro to the lab, if all your forces going down have to be balanced by the force going up, and we're not going to change any of our forces. And I'm going to give you where to place the masses. So in trial 1 you have 85 and 15, trial 2 95 and 5, and then so on and so forth. And I worked out you need to show work for this entire first trial. This lab isn't difficult, but it's a little tedious. Okay, here's a picture. This picture is actually on the web page, so if you want, don't have to watch the video if you want to see it again. This is my force 1, which is the force that we just calculated, showed you how to calculate. Your center mass force is the mass of the whole stick times 9.8, and it will be almost certainly right at the middle at 0.5. And I'm reading left to right. I've got my P's here. P1 is the position. That tells you where to place it. It's not the length, it's the position from the end. So I told you this one was 85, this one was 5, and then I only give you the left and right positions. You have to determine where to put the pivot point. I have to find the position to put the pivot point to balance it. Okay, in my example it balanced at 44 centimeters or 0.44. So, but you'll have to adjust that. Okay, so that I can't give you that because your weights may be a little different than mine. Then to actually do the lab, we need these measurements. So the first thing I'm going to do is, remember in the intro I said you could sum, your torque should sum to 0 no matter where you're at. Okay, so we're going to sum around number 1, which is right over here. So I need the length from each force. So I have the length of the center mass force to force 1. Now the length of force 1 to force 1 is 0, so this one does not contribute to the torque. So all you have to do is get in your table on your in your notebook and you just work your way across. You read what you measure that distance, and once you have the positions, you can just subtract them. You don't have to worry about plus or minus. You just always use a positive length. Then you'll have to look at it. So I take this is length from the center mass to 1, and I multiply that by the force, and that gives me the torque that's going this way, and that will be a clockwise force. In my notebook, I actually had them backwards on my first two trials. My force of the pivot is right here. I measured that distance. I measured that distance times that force. That gives me a clockwise force. From this force and this distance, I multiply this distance times this force, and that gives me a counterclockwise torque. So here's the part of the notebook where I did that. You just work your way through the left to right on the table, and you have to find the torque of 2 to 1. And so that's the force 2 times the distance from 2 to 1. And you just work your way through. The only thing you really have to think about that's different from trial to trial is you have to decide. There is no set formula for which one's counterclockwise and which one's clockwise and counterclockwise. You just have to look at them and think which way will it make it spin. So in this case, my center mass and my force 2 will make it spin this way, which is counterclockwise. My pivot makes it spin this way. Just real quick, point out a couple of other items. If we go to the second, when I'm spinning around F2, then my F1 and my center mass force are now making it clockwise, and my pivot's counterclockwise. When I get to where I'm summing the torques around the center mass point, now all of a sudden the pivot works with force 1 in this case. In later examples, it may work with force 2, but the pivot is making it spin this way, which is clockwise. F1 is making it spin clockwise. F2 is making it spin counterclockwise. So just make sure you keep track of that. Again, this lab isn't, the math's not difficult. Hopefully you can understand the ideas, but it is a little tedious to get. Once you get in a rhythm, though, by the time you do your third trial, you should be able to do it fairly quickly. Collecting the data is really fast. All you have to do is get it balanced, and then you can read the distances. Once from the positions, you can get everything, and you only have to do the masses and the forces once for the whole lab. So the data collection should take you about 5 or 10 minutes. If you want to do all the data at once, you can, but as you can see in my notebook, your percent error should be under 1 or 2%, because mine were all under 1%, and I'm no smarter than you guys are. So good luck.